So, in the previous video, we have looked at this question, but there are factorials everywhere on the top. So it's going to be 3 factorial, 4 factorial, and so on. And we've discussed the solution to that question in the previous video. But in this video, we're going to calculate what if there are no factorials at the top. So, just like in the first video, we're going to try to generalize this question with variables. So let's take a look at it. At the numerator, there are going to be integers from 3, 4, 5, all the way to 100. So let's denote that with a variable. Let's say n. And then we're going to divide it by, at the denominator, we have 1 factorial, 2 factorial, 3 factorial, and so on. So basically, these are going to be the consecutive numbers. 1, 2, 3, 2, 3, 4, all the way to 100. So we can write it as, well, firstly, 3 and 3 are the same, 4 and 4 are the same, so n with n factorial. And then 2 is 1 less than 3. So you can say we sum it with n minus 1 factorial. And then the same thing for 1 factorial, that is 1 less than this expression. So you can say plus it by n minus 2 factorial. So we're going to get this expression. And then we can evaluate it even further. So we're going to have n at the top, and then divide by all of this. So firstly, let's take a look at an interesting property of factorials. Let's say we have 5 factorial. By the definition of factorial, this is basically 5 times 4 times 3 times 2 times 1. But what if we take the 5 over here, so 5, and then multiply by all of this, 4, 3, 2, 1. That's the same thing as 4 factorial. And this is the same thing as 5 factorial. We can use this expression to evaluate some of these. For example, let's say the n minus 2 factorial. We're just going to keep it that way for now, n minus 2 factorial. But for n minus 1 factorial, we can say that it's basically n minus 1 times by n minus 2 factorial. We're just using this property right over here. And the same thing goes for n factorial. We can use the same property. So we're going to add it with n times by n minus 1 times by n minus 2 factorial. And now we can take a look at this. N minus 2 factorial, n minus 2 factorial, and n minus 2 factorial. We can factor it out. So we have n divided by, we can factor out n minus 2 factorial. So we have n minus 2 factorial. Then we're going to multiply it by, let's see, for this expression it's going to be 1. For this expression it's going to be n minus 1. So plus by n minus 1. And for this expression it's going to be n times n minus 1. So plus it by n times n minus 1. And then we can simplify it even more. 1 plus n minus 1 is basically just n. And look at it. There's n in here, there's n in here. We can factor out n. So this is basically the same thing as n divided by, don't forget n minus 2 factorial, like so. Then multiplied by, we factor out n for both sides. So it's going to be n times by, this is going to be n times 1, so we add 1 plus by n minus 1. However, we do know that 1 plus n minus 1 is basically just n. So then we can rewrite this fraction into being n divided by n minus 2 factorial times n times n. So basically, n minus 2 factorial times by n times n. So now we can cancel out the n in here with the n in here. And now we'll be left off with this expression. 1 over n minus 2 factorial times by n. And even, we can evaluate this even further. So let's take a look at this. N minus 2 factorial. So we can say n minus 2 times by n minus 3 times by n minus 4, and so on. And then we're going to multiply by n. If we add n minus 1 into this expression, if we add n minus 1, then this is going to be n factorial, right? N minus 1, n minus 2, n minus 3, and so on. So we can rewrite this as n factorial. However, we have just added one new expression, n minus 1. And we can just add a random expression into the equation. It won't hold true. So we're going to divide it again by n minus 1. So we didn't change the value. We just add in n minus 1. So it's going to be n factorial, but then divide it again by n minus 1. So we didn't change any value. We have just rewritten this. So now we can rewrite this fraction into being 1 divided by this, n factorial over n minus 1. So it's going to be n factorial divided by n minus 1, which we can bring up this to the top. That's going to be n minus 1 divided by n factorial. And we're going to get this simple expression. But we can simplify it even further. So we obtained the expression n minus 1 divided by n factorial. Firstly, we can simplify this even more. We can break up the fraction into being n over n factorial minus by 1 over n factorial. And then n factorial is basically just n times n minus 1 times n minus 2 and so on. So then the n cancels out. So this becomes this expression, which, if you recognize, is going to be n minus 1 factorial. So we can rewrite this as 1 over n minus 1 factorial minus by 1 over n factorial. And we've got this expression. So what if we input into n being 3, 4, 5 until 100? So let's think about it. If n equals 3, we're going to get 1 divided by 3 minus 2 is 2 factorial. And then we're going to minus by 1 divided by 3 factorial. And then if n equals 4, we're going to get 1 over 4 minus 1 is 3 factorial. And then minus by 1 over 4 factorial. So if we do this, we're going to get the series 1 over 2 factorial minus 1 over 3 factorial plus 1 over 3 factorial minus 1 over 4 factorial. And then we can continue on until we reach, if n equals 100, we're going to get 1 over 99 factorial minus by 1 over 100 factorial. And look, this cancels out with this, and this cancels out with all of this until this expression. And lo and behold, we get 1 over 2 factorial minus 1 over 100 factorial. And we can rewrite this, because 2 factorial is basically 2, into becoming half minus 1 over 100 factorial. And there you go. That's going to be the answer to this question.